Alright, this is 2-4 notes on 2D figures. Your objectives, you'll be able to identify and name polygons, and also you'll be able to find perimeter, circumference, and the area of two-dimensional figures. So this stuff is a little bit of a review from maybe previous years, but we just have to make sure we know this material so we can do the more challenging material. So some history. Most of the closed figures shown in the Mosaic time periods are polygons back in the day. So a lot of those like glass structures that you might see around in your life, when it's all a bunch of triangles and polygons and other shapes put together via glass, those are typical times of the Mosaic times. You see a lot of that stuff being built. The term polygon is derived from the Greek word meaning many angles. Here's some more pictures of his many angle figures. So some other vocab here. Polygon is a closed figure formed by an infinite number of coplanar segments called sides, such that the sides that have a common endpoint are non-collinear, and each side interacts or intersects exactly two other sides, but only at their endpoints. So as you can see here in the picture, you have a line segment, and at the end of each line segment is the start or beginning of another line segment going another. So that all the line segments are connected at endpoints. In other words, they can't be crossing in the middle of each other. There can be several vertex in a polygon. Each vertex on it is a vertex of a polygon. So, to identify vertexes, vertex are the points in which two line segments meet. So that little red dot's a vertex. This little red dot's a vertex, and this one is a vertex. So how many vertex are there total? That's 1, 2, 3. So there's 3 vertex in a triangle. Looking at this figure, the side of the box and the top of the box, they meet up there. Top of the box and the right side of the box, they meet there, there, and there. So this has a total of 4 vertex in the polygon. So when the polygons get bigger, you just count up the number of corners. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one has 9. So it's just really just counting up the corners. This one, 1, 2, 3, 4, 5, 6. So that's a 6-sided polygon. I think you get the idea. Do's and do nots. Polygons, they look like these type of figures that you see over here, where it's just all the sides where each endpoint is being connected. So these 3 examples are polygons. Some not polygons, well, if 2 lines cross each other like this, that means it's not a polygon. So you can't have, polygons cannot have 2 lines crossing each other. A flag, that's not considered to be a polygon. Those polygons are made up, you see they're all straight edges. You can't have curves. So that's why that one's not a polygon. The circle was not a polygon. And this one is not a polygon because they don't connect. So this piece, this piece, this piece, this piece. However, it doesn't become enclosed. It has to be enclosed. So if this had another line right there, then it would be a polygon. However, since it doesn't have that extra line connecting it or closing it out, it's not a polygon. Next thing up is a convex polygon. A convex polygon is when all the sides is all like spread out and stretched out. And a convex polygon is also better explained, let's say, if I tell you what this next polygon is. So if you do convex, if you were to take a hammer and you were to bash this side in, so this corner is going to get bashed in with my hammer. Not the best hammer in the world, but you get it. So I'm going to take a hammer, I'm going to smash that side in. So I smash it in, smash it further, further. When it's smashed in, that nail, it turns into a concave polygon. So if there's an angle, say it's smashing in, concave polygons, if any of the lines contain any point in the interior of the polygon, so it's on the inside of the polygon shape, then it's considered concave. So the concave polygons is when there's a point on the interior, and convex is when there's no points in the interior of the polygon. So if it's smashed in, it's considered, one of the sides gets smashed in, it's interior, it's considered concave. That's the best way I could describe that. So some names of polygons: if it has 3 sides, it's considered a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 is a heptagon. 8 is an octagon. If you want to go a little higher, 9 sides is a nonagon. 10 sides is decagon. 11 side, the hendecagon. 12 is dodecagon. And then anything above it, you could just say engon. So 13 or above. Because most polygons are going to stick with 12 sides. To go any higher, engon is totally fine and acceptable in the math world. Alright, so equilateral polygon is when all sides are congruent. So equilateral is when all sides are congruent. Equiangular, when it's the angles that are the same, that means all the angles are congruent. So equiangular polygon is all angles are congruent. And the word congruent, if you didn't know what that was, that means the same or equal to. That means all the sides have the same length, or all the angles have the same length. So that's the definition of congruent, if you didn't know that already. So when you have all the sides that are the same, that's an equilateral polygon in this picture. How about looking at this picture? Is it an equilateral gon or equiangular gon? Well, you can see that all the angles are the same and all the sides are the same. So let's just actually I meant to get rid of all these sides. This is just meant to be all the angles. So, whoop. Anyway, this was meant to be all the angles just be showing, so it's an equiangular polygon. And what you see here, all the angles are the same, so it's equiangular. Regular polygons are both equilateral and equiangular. So when it has both the angles and the sides, that's considered a regular polygon. Perimeter, well, the perimeter is just the outside lengths all added up together. That's the perimeter. So you just add up all the sides. Circumference is the perimeter of the circle. An area is the interior, the inside of the figure. So let's say that we have this. Let's draw a shape for perimeter. So let's draw a triangle. And we say that this length is 5 feet from here to here. The length from the top to the bottom right is considered 7 feet. And in blue on the bottom, let's consider that 10 feet. So the perimeter will be 5 plus 7 plus 10. So that the perimeter will be 22 feet. Just add up all the numbers to get perimeter. Area, let's say we have a rectangle. The height of this rectangle is 2 feet. And the width of the rectangle is 10 feet. The area is the inside, so we multiply them. 2 times 10 gets us 20. Just like you did in middle school. So that's how you find area. Alright, so let's get a little crazy. Or a little bit more different style polygons that you might not have seen before. So, if you have a polygon like this, and we have to find the perimeter, what we got to do is just add up all the numbers. So this length over here is 9 meters. From here to here is 5 meters. From here to here is 4. From here to here is 6. And from here to here is 8. To find the perimeter, we just add them all up. 8 plus 9 plus 5 plus 4 plus 6. So right here along 5 plus 4 plus 6 is 15. 15 plus 9 gets you 24. And 24 plus 8 gets you 32. So the perimeter is 32 meters. Is the perimeter. Let's find the perimeter of Super Mario. Even though it's not labeled, you could just count up the boxes. 1, 2. Actually, let's make them bigger so it can fit on your screen. There we go. Alright, let's do in blue. So this has 1, 2, 3, 4, 5 boxes up top. 1 going down, 3 going across, 1 going down, 2 going across, 1, 2 across. You could just literally count them all up. 1 going down, 1 going across, and then you just add them up all the boxes going around the figure, and you'll get the perimeter of Mario. Same with Charmander. You just add up all the boxes going around. That'll get you the perimeter. Here in Yoshi, you can do the same story too. 2, 3, 1, 1, 3, 1, 1, 4, 1, so on and so forth. Label all the numbers and then add them all up. So a figure like this. It's tricky. They don't give you all the information. You have to find some pieces of information to figure it out. So we know from top to bottom here on the left side is 12 millimeters. From left to right is 15 millimeters. From here to here is 7. The blue line is 8 millimeters. This height we don't know. And the purple length we don't know. So we're going to have to use some common sense here. Do you see that this red top this red piece plus this blue piece, these two pieces added together make the purple piece? It's the same length. Small plus small equals big. So this 15 plus this 8 is going to make this purple piece. So 15 plus 8 gets us 23 length on the bottom. This piece over here, this black piece on the right side, that piece plus this 7 piece is going to equal the 12. So if we do 12 minus 7, that'll get us this length of 5. Now that we know all the side lengths, we then just add them up to find the perimeter. So 15 plus 7 plus 8, well, that's 30. 5. 35 plus 23 is 58, and 58 plus 12 gets you 70. So the perimeter of this guy is 70. Look at the letter E here. We got to find the perimeter. Well, not all of them are labeled, so we're going to have to use some matching skills here and figure out what pieces match up with what. So this little 1 tick is 14. So everywhere we see a little 1 tick, that's 14. So 14 there, 14 there, 14 here, and 14's here. We don't know the length of the bottom, and we don't know the length of this E. However, this is 25 right down below it. That also got to be 25. From here to there is 50, so that means this bottom piece is 50. Now, we can see the top length of the E is the same as the bottom length of the E. So 12 plus 50 is 62. If that's 50, this means this is 50. And we filled them all in here. Now we add up all the sides, and we're going to get our perimeter of the letter E there. So you could handle it. Alright, so here's your classwork and your homework. If you have any questions, feel free to email me or come next show. I'll be happy to help you out. Alright, have yourself a good night.